Question 5. Nitrogen monoxide reacts with chlorine to form nitrosyl chloride, NaCl, and I've got an equilibrium reaction here. 1.5 moles of NO are mixed with 1 mole of Cl2 and the mixture is left to reach equilibrium. So when I mix the two reactants on the left, I actually haven't got any products on the right initially. So I haven't got any of this NaCl made at all. But then in the equilibrium mixture, it tells me I've got 0.350 moles of NaCl. Calculate the number of moles of NO and Cl in the equilibrium mixture. So once dynamic equilibrium's reached. I always set this out as a table. I can see it more easily in a table, so I suggest you do too. So let's put the three chemicals, the two reactants, the NO and the Cl2, and then the product, the NaCl. And then let's say how much we've got the start. So at the start we've got 1.5 moles of NO. It tells me that I've got 1 mole of Cl2 and I've got no moles of NaCl. No surprise because I've not made any yet. I've not mixed them yet. So when I mix them and I wait for equilibrium to be reached, remember that's the point where the concentrations of the reactants and the products no longer change and the forward and backward reaction are going at equal rates. Then it tells me that I've got 0.35 moles of NaCl. Well, I can look at my molar ratios here in my equation to see if I've made 0.35 moles of NaCl. 2 moles of NO would react with 1 mole of Cl2 to make 2 moles of NoCl2. That's a molar ratio 2 to 1 to 2. So the number of moles of NO used up equal the number of moles of NaCl made. So I've used up 0.35 moles of NO to make 0.35 moles of NaCl because there's a number 2 there and a number 2 there, the equal number of molar ratios. The number of moles of Cl2 is only 1. So I've used half the amount of Cl2 that I have of NO. So I've used half the amount of this. So it's 0.35 divided by 2. I've used up 0.175 moles of Cl2 in my molar ratios. Now, this is how much I started with. I've used up 0.35. Remember, this is a reactant reacting away to make the product, the NaCl. So to subtract these two, I've now got left over 1.15. Same for Cl2. I started off with 1 mole. I've used up 0.175, so I've got 0.825 moles left over, and I've made 0.35 moles. I didn't have any to start with. I've made 0.35 moles, so I've now got 0.35 moles. Give the expression the equilibrium constant Kc for the reaction between nitrogen monoxide and chlorine to form nitrosyl chloride. So what I do is I take the concentrations of the reactants, of the products NaCl, and I raise it to the power of 2, that's the number in front, divide by NO, that's one of the reactants, raised to the power of 2, divided by Cl2 to the power of 1, because there's a 1 in front of the Cl2. So it's NoCl2. Concentrations, remember, are in square brackets. NoCl2 in square brackets raised to the power of 2 divided by NO in square brackets to the power 2, Cl2 to the power 1, because there's only a 1 in front of the Cl2. A different equilibrium mixture is prepared in a flask of 800 centimetre cubed. Remember, 800 centimetre cubed is 0.8 decimetre cubed. 10 centimetre cubed up into a higher unit value of decimetre cubed, I divide by 1000, 0.8 decimetre cubed. That'll be important in a moment. At equilibrium, this mixture contains 0.85 moles of NO and 0.458 moles of Cl2. For the reaction, the temperature, at this temperature, Kc is 1.32 times 10 to the minus 2. So the reason Kc has changed is because the temperature has changed. The equilibrium constant would stay the same if the temperature stays the same. So Kc only changes if you change temperature, but we have changed temperature, so that's why Kc has changed. Determine the amount of moles of NaCl in this equilibrium mixture. So my expression for my equilibrium is still the same for my equilibrium constant, but the equilibrium constant has changed to 1.32 times 10 to the minus 2. Still equals NaCl concentration to the power 2 divided by NO2 concentration to the power 2 divided by the concentration of Cl2. What have I been given? It contains 0.85 moles. So concentration is moles divided by volume, 0.85 divided by a volume. Volume is in decimetre cubed because concentration is moles divided by volume in decimetre cubed. So to turn centimetre cubed up into decimeter cubed, a larger unit value, I divide by 1000, 0.8. So NO's concentration is 0.85 divided by 0.8, still to the power 2 here for my expression, and this one 0.458 moles of Cl2 divided by 0.8 again, so that's the number of the concentration is number of moles divided by volume, and they're in the same flask, so 0.8 is my volume. So I can work these out. 0.85 divided by 8 squared, 0.45 divided by 8, and multiply those. So when I rearrange the equation, then these are on the bottom on the right hand side, they get to the top on the left hand side. So 1.32 times 10 to the minus 2 multiplied by 0.85 divided by 8 squared multiplied by 0.45 divided by 8 comes out as 8.53 times 10 to the minus 3 is the concentration of NaCl squared. Square root both sides, so NaCl concentration is now equal to 0.0924. Number of moles is concentration times volume, so I've got the concentration, I've got the volume, which is 0.8 because they're in the same flask. 0.0924 multiplied by 8 is 0.0739. Have a look at my other values: 3 significant figures, 3 significant figures, 3 significant figures, 3 significant figures, everything's to 3 significant figures, so I can put that as 0.0739 to 3 significant figures.